So we are going to talk about a lie detector that we have made. First, let's introduce ourselves. I'm Sita.
I'm Tammy.
I'm Yui.
I'm Libby.
Here's the table of the contents. So, first, what inspired us to make a lie detector? Have you ever wondered if someone is telling the truth or lie? We decided to make a lie detector for this situation to know if someone is telling the truth or not. Will prove useful in many different cases. For example, it helps enhance sustainability. First, environmentally, by ensuring that supplier adhere to sustainable practices and maintain an environmental responsibility. Next, socially, by solving from a small misunderstanding to a serious count matter. And also, economically, by enhance the credibility and reliability of many companies and much more. As it can be seen, modern days lie detector come with unlimited responsibility and application in many different fields.
So now I'm going to talk about the design process behind the project, including the equipment. And so here we use the Arduino, which was the main controller for the boards, and it was important in processing the input changes in skin resistance. And we also use resistors to avoid short circuits and overheating. We used wires as well to ensure firm connections between components, and it was very important because it helped us get signals from the user's skin. We used different LED colors to represent different things, such as red for lying, green for truth, and yellow for uncertainty. We used the breadboard as well for providing a firm base for the connections and components. And we also use the IDE software to develop a control code for the Arduino, which included port configurations and codes verification. We also used the 3D CAD design to design a case box for the lie detector. And to break down our steps even more, we created this flowchart to see the process more clearly. We made goals and objectives first, and then we allocated tasks to each person. Testing was the main part of our design process because we had to make sure we obtained the expected results. And once we obtained them, we used Excel to analyze the data, and then we used CAD to design the container, and yeah, we summarized it and now presenting.
Okay, so here we're going to talk about the operations of this lie detector. So how does it work? Working up behind this lie detector, based on these researches, it has been proven that there is a connection between galvanic skin response, or in simple terms, changes in skin resistance as a result of a change in human emotion or nervousness. From there, we created a lie detector, which is a device which measures those changes, compare data, and interpret them to the users if the person is telling the truth or a lie. Here's our schematic plan of the device. Using potentiometer to represent the change in skin resistance, the data is inputted into the Arduino, which is our main central controller and processor in this case. The Arduino then compare the value to the preset threshold and provide voltage to the corresponding LED, which is red, yellow, and green. And each color represents different meaning, as stated before. And here is our plotted signal, and it is clearly shown that there is a shift in skin resistance every time the person tells a lie. Then it will gradually decrease to the normal resistance. Yeah, as you can see from the graph. However, we believe that more improvements can be done for this device.
So lastly, to the evaluation, what we can improve. So we can reduce the noise as shown in the graph just now. There are a certain degree of fluctuation, and how to improve it, we can add a capacitor to smoothen the signal, and it is a cheap and easy way to do so. We can also improve the resolution of the hardware, but it may require more funding. And we can also separate the circuit into two to avoid the direct contact to voltage source for the users. And here is our references. And thank you.